Okay, this is a presentation on the Neutronics Material Maker. This is an open source package. The source code can be found on UKAEA GitHub, and it's able to make your OpenMC, Serpent, Fispact, MCNP materials. There are examples on the GitHub page on the left here, and there are also examples on the documentation. Here are the examples on the documentation. But it's always useful to have a walkthrough, so let's do that. So you'd start off in your Python environment by importing Neutronics Material Maker. I import it as NMM, but that's up to you. And then you would want to make a material. So we would make a material by giving it the name of the material that we want to look up from the internal dictionary. So I'm going to go for Inconel, and then I will set that equal to my mat equals, and then we have an object here, and it can be exported in a variety of ways. So the easiest option is OpenMC material. So there's Inconel, and it's been looked up from this internal dictionary, and all the isotopes have been assembled. You can also export a Serpent material if you prefer. Here the /n's indicate a new line, and you can export an MCNP material as well. Before you export an MCNP material, you need to also specify the material ID that you'd like to use. So material ID 10, and then MCNP material is made, again, /n's indicate a new line. You can see M10 there. You can also output a Fispact material, but in this case you need to specify more information because Fispact needs to know the number of atoms, so it would need the volume to work out. So let's make it 40 centimeters cubed, and then the Fispact material is a dense string again with /n's to indicate a new line. So how do you find out what materials are actually available? Well, you can have a look at all the materials available by inspecting the available materials property. Now this is all the materials here in a gigantic dictionary, which is possibly too big to be useful. So you can ask for just the names of the materials, and now you've got a smaller dictionary. In total we have 418 materials, and this is largely thanks to PNNL for their fantastic materials compendium. Another way of finding the materials is to go into the source code and to have a look at the data. So these are separate JSON files, and this is a PNL JSON file, and you can see it's got a lot of materials, and each material has got elements and a reference and a density. So that is very useful, and some materials are a little bit special. They have additional features, so let's have a look at the next example. So the examples are a hot pressurized material. So in this case we're going to make a material which changes its density depending on the temperature and pressure. So we could have H2O, and we can set that up like that. Now this will only work if it's got the temperature and pressure defined, and if it doesn't have those two inputs, it will tell you that it needs them. OpenMC material. So there's the density, 0.72. So if I raise the temperature from 3 to 400, we can see the density drops. And if I increase the pressure from 15 to 25, the pressure also changes the density. Great. There are other types of materials as well. So these are breeder materials with crystal structure, things like lithium orthosilicate. The way they're defined is by a chemical equation, but they also have material atoms per unit cell and the volume of the unit cell, which means as we enrich it, we can substitute out one atom of a lithium-6, for example, instead of the natural lithium. It's got the enrichment target pre-coded as lithium-6, and the density will change. So let's try that one. So here you have lithium orthosilicate, and it's got a density of 2.3. But if I specify an enrichment of 90, remember natural and lithium-6 is about 7%. So we'll see that density go down, 2.3 to 2.25. And you can see the lithium-6 is 90% lithium-6. Now you can specify any enrichment isotope you want, and we could change it to lithium-7 if you so desire. So now we're doing 90% enrichment of lithium-7. We see these two numbers have switched around and the density has gone up, as you would expect. Now there is another way of making materials using a dictionary. So these dictionaries are very similar to the dictionaries you'll find in the JSON files in the data section of the source code. And you can use them in the following way. So we define a dictionary, and this is going to be called, we've made up our own name, Li with Si. And it's got two elements in these relative abundances, and it's got a density and the units and the density type. And then we can make a material from an expanded version of my dictionary. That's what the double stars does. And I'm going to do my mat2 equals, great. Then you can export this in the same way, OpenMC, MCNP, Fispact, Serpent. And you can see it's got the elements which have been broken down into the isotopes, and it's got the density 3 that we assigned here. So this could be a file that you've read in of your own materials. If you don't want to use inbuilt 400 odd materials, you can always make your own. The other aspects of this are you can define them by isotopes. So let's have lithium-6 and silicon-29. We won't have them all. And you can see I've just got those isotopes as well. You can also define them as a chemical equation, like I've done here. So you can say chemical equation. So there I've put the chemical equation in as a string, 4 atoms of lithium to every 2 atoms of silicon, and then there it is made. The last thing I'm going to show you is how to make mixed materials, also called multi-materials. So there's examples for this again on the website, but we'll just walk through it now. We have 2 materials, my mat and my mat2, so let's use them. So this will be a mixture between lithium and silicon and more lithium and silicon. That doesn't sound ideal. Let's change this to beryllium-12 titanate. There we go. So now we're mixing beryllium and lithium orthosilicate. That makes more sense. Just like you might find in a breeder blanket. So here we see we've got my mat3 is a Neutronics Material Maker .multi-material object. It's got a material tag, and it's got 2 materials that it's made of with these fractions, and these are volume percents or fractions. So we can run that, and then we can have a look at the contents. Again, these are available as MCNP materials, but you need to put in a material ID for it to be recognized. You can have them as Serpent materials and Fispact materials and OpenMC materials. Okay, great. Hope that made sense. If you have any issues, feel free to raise an issue on the Neutronics Material Maker GitHub page and I will get back to you.